Welcome to Ms. Math Presents Geometry SOL Prep G3 Transformations. It helps to remember Hoy-Vux from Algebra 1. Hoy, horizontal, zero slope, y equals a number. Vertical, undefined, the equation will be x equals a number. For lines of symmetry, a line of symmetry cuts a shape in two symmetrical parts. Each part is a mirror image of the other. The rectangle that we see here in the graph has two lines of symmetry. First, we can cut it vertically. And if we look here, it goes through the shape. A vertical line is x equals a number, and it goes through at x equals 2. The second, a horizontal line, cuts through the shape at y equals -1. So there are our two lines of symmetry for this shape. A translation is a slide. So for this one, we're going to try an example of sliding this triangle 2 units right and 3 units down. Moving right and left affects the x value. So right would increase or add to x, and left would subtract. Up and down affects our y value. Up increases or adds to y, and down decreases or subtracts from y. If we're going right 2, we're going to increase our x value by 2, and down 3 would decrease our y value by 3. So our rule for this would be for any ordered pair, we could add 2 to our x value and subtract 3 from our y value. We can also do this on the graph. So from each point, let's start with J. We are going to go right 2 and down 3. So from J, I'm going to count right 2, down 3, and I have my new point J prime, which is at 3, -1. You notice our rule works for this. X plus 2, 1 plus 2 is 3, and y minus 3, 2 minus 3 is -1. Let's repeat the same process for our next point. We're going to start with point K, and we're going to go right 2 and down 3. Our new point K prime is at 0, -7. Repeat again for H, right 2, down 3. Our new point H prime is at -2, -4, -5. And you notice with each of these, our rule, x plus 2, y minus 3, works for all 3 points. When we draw out our new triangle, you can see this triangle just slid across the graph. That's our translation. A reflection is a flip. Our rule for these is that we count to the line that we're reflecting over, and then we count the same number of units on the other side of the line. We just have to be careful to make sure we know which line that we are reflecting over to be able to do this. So we're going to try a couple of different reflections. First, we're going to flip over the line y equals 0. First, I'm going to highlight it so I know where I'm counting to. You notice y equals 0, that's a horizontal line. It goes right across the x-axis. So I'm going to start with point J. I need to count to the line. So I count down 1, 2. And now I need to count on the other side of the line the same number, 1, 2. So my new point J prime is at 6, -2. I'm going to repeat the same thing for H. Count to the line, count on the other side, and H prime is at 3, -2. Repeat again for K. Count to the line. I go down 6, and I count on the other side of the line. Again, 6. So my new point, K prime, is at 6, -6. You can see from the triangle that we have flipped it over that line. So it is a reflection. Let's try another one. This time we're going to reflect over the line x equals 0. First thing I'm going to do is highlight that line. X equals 0 is a vertical line, goes right over the y-axis. So for each of these points, I'm going to count to the line, and then I'm going to count the same number on the other side. Start with J. I count to the line. I count 6, so I'm going to count 6 on the other side. So my new point J prime is at -6, 2. Let's do the same thing with H. Count to the line. That's 3. Count 3 on the other side. My new point h prime is at negative 3, 2. Repeat again for k. Count to the line. Count the same on the other side. And k prime is negative 6, 6. I draw my triangle, and you can see that the triangle flipped over that y-axis, or the line x equals 0. Let's try another one. What if you were asked to reflect twice? This time we're going to go over the line y equals 0, then over x equals 0. So the first thing we do, highlight our lines. Now, this one's a little trickier. We got a couple of things we have to remember. We have to repeat the same process for the second reflection. We also have to remember we make sure that they're done in order. So first we're going to flip over the line y equals 0, then over x equals 0. Let's start with point J. We're going to count to the line y equals 0, 1, 2. Count on the other side, 1, 2. Now I'm going to repeat the same thing for my next reflection. From that new point, I'm going to count to the line x equals 0, and then on the other side. I count 6 to x equals 0, and then I count another 6. So my point J prime is at negative 6, negative 2. We're going to repeat the same thing for h, to y equals 0, on the other side, and then again to x equals 0, and to the other side. So h prime is at negative 3, negative 2. Once again for k, count to y equals 0, count on the other side, then count to the line x equals 0, and to the other side. So we have k prime at negative 6, negative 6. We draw our triangle, and we see that our triangle flipped over the line y equals 0, and then again over the line x equals 0. One last reflection to talk about. This one we have a little trick for, but let's actually work through it first. We're going to reflect over the line y equals x. So this one's not across an axis, but it is a straight line going through the origin, because if y equals x, then when x is 0, y is 0. But it also goes through at every point, 1, 1, 2, 2, 3, 3, and so on. It has a slope of 1. So this line is going to go corner to corner on our graph, straight through the origin. Now, for this one, when we count to the line, we're going to have to change direction on the other side. So I count from J to the line, 1, 2, 3, 4. And then I have to change direction. If I kept going on to the left instead of changing direction, then I would be reflecting over a vertical line at x equals 2. So I can't do that. That's why we have to change direction. Doesn't matter which way you go as long as you switch directions. I went to the left, so I'm going to go up. If I had gone up first, then I could have gone to the left second. So either way, we wind up at the same point. So we go from J to the line y equals x, and I counted 4. I'm going to change direction. So I'm going to go up 4, and there's my new point at J prime, 2, 6. Same thing for h. I count up 1, change direction, left 1, and h prime is at 2, 3. K, you notice, is on the line, so I don't have to count anywhere. That's going to stay put. I can draw my triangle out, and you see that it reflected over the line y equals x. Now, we do have a trick on this one. Let's take a look. If you notice, each of these points, x and y, changed places. So our shortcut here is you can take your point xy, and when you reflect it over the line y equals x, y literally becomes x. So you're just switching the place of the ordered pair. So you'd write it as yx instead. So 6, 2 becomes 2, 6. 3, 2 becomes 2, 3. 6, 6 is the same because when you switch it, it doesn't change. Next up, we're going to talk about rotations. A rotation is a turn. So for these, you actually will just turn your paper. So when you have your paper with the graph on it, you're going to literally turn it. Remember, clockwise goes around. If you're going at the top, it goes to the right. Counterclockwise from the top goes to the left. And then 90 degrees is one turn, 180 degrees is two turns, 270 degrees is three turns. For this one, we're going to do a 90 degrees clockwise rotation. So what I'm going to do is I'm actually going to take my graph and I'm going to turn it. So now I'm going to pretend like, I know you see these numbers up here that say -1 to -6 at the top. We're going to ignore those and pretend we're looking at a regular graph. We're just going to read our new points. So A, which started out at -5, 1, is now at 1, 5. Point B, when I turn the page, I count over 6 and up 1. So 6, 1 is my ordered pair for B prime, and C prime is at -1, 2. Last transformation to talk about is a dilation. A dilation, we're just changing the size. So all we do is multiply. So we're going to dilate this triangle by a scale factor of 3. Scale factor tells you what to multiply by. So my point D, -2, -1, I multiply that by 3. So that becomes -6, -3. Point E, 1, 1, I multiply by 3, it becomes 3, 3. And for point F, 2, -2, multiply both of those numbers by 3, I get 6, -6. So there's my point F prime. And if I draw out that triangle, I can see that it's the same triangle, but it changed the size. So that is our dilation. That's all for G3 transformations. Thanks for watching. See you next time.